This is industrial networking project number 1, DeviceNet project number 1. This is industrial networking. We're doing the DeviceNet project number 1. And we'll look at what we're supposed to be doing. So we're supposed to connect the PowerFlex 40 to the DeviceNet. This I've already done. I put a communication hardware in. Then I need to configure the DeviceNet so it sees my PowerFlex 40. So that's what we're going to do next. So we'll come up and we need to have the RS Link program up and running. So we'll come up in RS Link and have it running in the background. So I have communications. And here we come. And just for the heck of it, we're going to go and check and see if we can see what we need to see on RS Link. And there's the DeviceNet scanner, the DeviceNet, and a whole lot of things on it, but I know that they're not there because I didn't hook them up. So those are things that are legacy items from this RS Link and aren't necessarily there right now. So anyway, RS Link is up and running. That's all we care about. And then we're going to come up in a program called RS Network for DeviceNet. RS Network for the DeviceNet. And here we're going to make a program that sees only the things that we want it to see. And this particular program, when we save it, will have to go into our control logic program, our RS5000 program. So, and that's why it says do this second. The other thing you're going to need, which I already got, was the processor and the DeviceNet card that is in our control logic. Okay, so what we're going to do is go to New, because obviously this is a new configuration and we want a new DeviceNet configuration. All right, and then we're going to go find it. And so there's 1, 2, 3, and there's the DeviceNet scanner, there's the DeviceNet. And you notice that when I was back on something else, we'll move back, the OK doesn't say OK. So the OK doesn't say OK, the OK doesn't say OK. But as soon as I get to the DeviceNet, it says OK. So now I'm going to go and scan the network for the devices that are on it. And this is going to take some time. So what I'm going to do is I'm going to stop the video. No, well, it's not going to take that long, I suppose. But it has to look for addresses all the way up to 64. And we're at 2 already. So we'll keep the video going just so you can see what it's doing. And there's the PowerFlex so that was cool that we had its address be 7 so that it would be a get there soon and have something to look at. The next thing we should see is probably the I have a electric eye guy hooked onto the DeviceNet network right now that I was using to just see if I could see it. That will be the next guy we see. And then the DeviceNet scanner, I think, is all the way up at address 63. And we're gonna have to wait for this all to scan the whole network. We don't really have a choice there. So don't be hitting cancel. Don't be hitting the red mark. Let it do its thing. Well, it is rather boring, isn't it? Okay, I'm gonna pause the video. So we made it all the way up to 63, and we see we do have a electric eye, and we're gonna cut it because we don't need it for this project. So that's what you do. You cut out anything that you don't necessarily need. The next thing we're going to do is we need to know everything there is to know about these devices. And that's something that we can't do manually. So we're going to go as network, and we're going to upload from the network everything that can possibly be known about these devices. So in the case of the PowerFlex, there's all the programming parameters that could be loaded in. In the case of the DeviceNet, there's all the locations and all the integer files that are associated with it. Okay, so now we have all that information. We're going to click on the PowerFlex because we left it in 3-wire control and variable speed and frequency control 0 to 10 volts in our last project. And that's not exactly what we want. So we're going to come and we're going to go and group our parameters so that they're grouped. And we're going to look at the basic programming parameters first. And we're going to say, well, the start source, we don't want it to be 3-wire control. We want it to be from the COM port. Okay, and the frequency control, where's frequency? Right there. Speed reference is now 0 to 10 volts. No, we don't want that. We want it from the COM port. So now the COM port is going to be controlling whether or not it comes on and off. Now, if you look at the diagram of your of the PowerFlex wiring diagram, you see that there's a wire hardwired in between pin 11 and pin 1. Currently that's not there. That's our emergency stop button on our last project. We're going to have to put that in order to make it work. I hope I remember to do that. But you see that we can also do all the advanced parameters, which we don't necessarily need for this project, and we can do the DeviceNet module itself, what speed it's going at, what it's doing. But that didn't change anything. It hasn't changed anything in the PowerFlex yet. But if we go network, download to network, then what it's going to do, it's going to load those guys in. But before we do that, we're going to look at the properties of the DeviceNet scanner, and that doesn't seem too bad. Right here is what we're worried about. What's on the scan list? Well, we obviously don't need those guys on the scan list. The scan list are the things that it's going to go looking for. So we're going to apply. We're going to take this off the scan list and put it back on. And we'll know why we did that later. Okay, so we're going to apply that. So now we're downloading it to there. We're going to look at the inputs. And we see the inputs to the DeviceNet scanner are located at data 0. So this is a dimensional data bit that's it's 32 bits long, and the inputs are located at data 0. The outputs are located at data 0. Now, the reason that we we took those other guys off the device list, off the DeviceNet scan list, was because they were also here in the inputs and the outputs. And then we moved the PowerFlex in and out so that it would be at input at data 0, which is where we want it for this particular project. And so that's just the way it is. Okay, so that being the case, we are ready to go to, oh, we have to save the program, right? So File, Save As, and we better put it someplace where we know where it is. So we'll leave it in Networks, that's fine, and we'll call it Fall 2015, and I'll use my name Doug so that I know where it is. And so that's the folder we're using, and we're going to save it as project, if I could spell project, number 1, DeviceNet. And we probably should spell DeviceNet correctly. Okay, and maybe if we're lucky we can find out where that is later. Notice that this guy's running. This program will have to be running in the background just like the RS link would run in the background when we're running the program. Okay, next thing we're going to do is we need to control the speed of a 3-phase motor over this DeviceNet using the PowerFlex 40. To do this, we're going to write the following program. So we have a program that needs to be written. Notice that it has interesting instructions in it, like a copy instruction, another copy instruction. So we're not using moves like we did before in 500. This is 5,000 stuff. All right, well, that being the case, we are going to go and see how we're going to write this program. So we're going to come up in an RS Logic 5000. There it is. Okay, and we'll start with a new project. And we know that our processor is a 1756L61 because we looked at it. We know that that's the case. The revision. So what revision is it? Well, that's an issue that will be resolved in the problem is if I open up the box, it'll say it's revision 1.9. But if I come into RS Link and I come up on that processor, where is it? And I look at the properties, it tells me that I'm revision 19.011. Okay, so that's where I would get the revision from. If I can pick a revision higher than that one, and then it would update to the new higher one, or I can just use 19. And in this particular case, I don't have much choice, do I? So I'm going to pick 19. I need to call it something. I'm going to call it Doug. I have a 7-slot thing, and the processor is in slot 0. And I'm going to create this in the 5000 project area. Okay, well that's fine. So I'm going to do that. And that already exists, so I'm going to call it Doug Project number 1. Oh, can't have number, but I can have 1. And I can call it DeviceNet net 1. Well, that seems like a reasonable thing to do. Okay, so now the next thing we're going to do is we're going to deal with the input-output configuration. Now, the way we dealt with that in 500 was we did a who's online, we came in, who active online, and then we read the input-output configuration. The way we do it here is that we add things that we need. So right now, I need a new module, and the module I need is a communication module, and it's going to be a DeviceNet scanner 1756 DNB, and I know that because I looked at the card already, so I know if that's the right one. Revision, I know it to be a 7, so I'm going to use revision 7, and I got that from the card. I pulled it out of the de-energized holder and looked at it, so I knew what it was. I'm in slot 3, so I'll change that to slot 3, and it's 7.1, and it needs a name. So we'll call it scanner. Okay, and we seem to be all right there. Now, if I look and I see I have a place for the RS network program that I just made. Okay, so I'm going to go and find it. So it's not in projects, it's in someplace else. Where is it? So it's in RS5000. No, it's not. Now I'm going to have to remember where it is. Alright, so we'll try it again. Come in through there. And program files. We'll program files. Rockwell software. How come I don't see okay, we're going to go back to the DeviceNet network file, save as, and so it's Doug, I got that. It's in the networks, I got that. It's in networky, I got that. It's in Rockwell software, I got that. And it's in the program x86 files. Okay, whatever you say, that must be where it is. Okay, so we come back to the to there. Okay, that's fine. And software, networky, networks, Doug fall of whatever. Okay, so we found it, and we're going to apply that to this particular program. So now the DeviceNet file we made in the DeviceNet network, network for DeviceNet, is now in our scanner, ready to go. Okay, now in 500 we had a group of of tags, addresses, our outputs, our inputs, and whatever. That's not true anymore. So the controller will have tags, and we look at them, and there are all the tags. So there's these local 3 inputs and outputs and status. Well, local 3 is this device net scanner. So I look at local 3 and I input and I see a run, status run, and then I got an output and I got a command register there, and then I've got the data. Well, this is the data that's going to and from the PowerFlex. And in the when I did the scan list and I put it on the scan list and I put it in a particular position, that's where it is here. The data itself is a double integer file that's 124 double integers long. Okay, so back to what we're thinking about. We're thinking about okay, we're going to come back to tags. There are program tags. There are program tags, and then there are controller tags. So the program tags are things that we have to make as well. So we have to make our own tags. That's the bottom line. So we're going to go to Edit, and we're making program tags. And on our piece of paper, you saw a partial list of all our tags. So if we go back to there, we see that there's the local guys. Well, you don't have to make them, but you do have to make these Boolean guys and these integer guys that are there. So we'll commence doing that. All right, so we need to have a drive command clear fault. Drive command clear fault. And we want to make the name to be as much as we can make it be. Now the data type is going to be Boolean, so that's basically a binary bit. That's all it is. So instead of having B3:0/4, we have drive command fault clear fault. All right, now we need a drive command jog. Drive command jog, and that's going to be a Boolean guy. And then we're going to go to the next one, and it says I need a drive command start. I could spell command. Now the spelling is not totally necessary. Now we're gonna look at, if I don't type in a B and get Boolean, these are the things that I could have tags for. And we look at them and we say, wow, well there's a limit guy, I recognize that. And there's a integer, and I can have a multiplexer, and I can move, and I can make a curve, and there's my timer. So if I wanted a timer, there's my timer, and someplace over here is a counter. There's the counter, so I could have a counter. So I can do those things, but I want the Boolean guy because that's what it says I want, so that's what I'm going to do, Boolean. Okay, next one is drive command stop. And he's a Boolean guy. And drive command, drive feedback. Well, it says drive feedback. we're going to change it so it says something slightly different. DRIVE, feedback. But this is really going to be the speed. And we want it to be just an integer. So we'll make it just an integer. Now, if we look at that guy, he's got 16 bits of Boolean in that integer. So we could use each of those things one at a time if we wanted to. We're going to use them as a the speed feedback. That means the PowerFlex is telling us what speed it's at. That's what that's telling us. And then we're going to find we need an output, drive output image, drive input image. So we'll do a drive input image. And we want that to be an integer, but we want that to be, so we want it to be an integer, but we want its dimension to be 2. That's what that little 2 in the side there means. So we're going to have a dimension 2. And when we looked at it's a double integer word coming from the PowerFlex. We're breaking that up into 2 integers. So half of that word is about speed, the other half of that word is about control, and we're breaking it into 2 parts is what we're doing. Then we need a drive output image. And that needs to be an integer as well. And of dimension 2. Okay, and then we're looking for a drive reference. Now let's be clear, that's the speed we want it to be at, and we want that to be just a single integer. And then we need a drive status faulted, which we don't want to see, and that's a Boolean guy. And drive status running, and we want him to be a Boolean guy. Now we have to make up the tags for everything we need. So I'm looking at the program now. So I look at the program, drive status ready, drive status active, drive status forward, drive status at reference. Why don't I see them? Drive command stop. Okay, I see that one. So I still have some other guys to put in here. So I need to put them in as well. And I need a drive command forward. So I need at least 1, 2, 3, 4 people, 4 more tags before I can call myself done. Okay, so we're going to go with drive status ready, active, and forward. On program. Drive status ready, drive status, if I could spell status, active, and drive status forward. And each of those need to be Boolean, so we'll change them to Boolean. Alright, so we'll go back and look at our piece of paper, and we're still looking for a drive command forward. Okay, so we're going to look for a drive. Command forward. And I think we need a at reference, right? Drive status at reference. That means that we have reached the speed that we're supposed to be at. And that needs to be Boolean, and this guy needs to be Boolean. Well, that didn't help any, did it? Alright, so that's probably all the tags we need. Now we're going to go to the main program, and we're going to look at the program tags. Those are the guys that we just made. And then we're going to go and write the program, and we're going to need runs up to 15. So where is our okay, back to running our program. We need 14 runs. We need 15 runs. So we need 15 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. In my first run, well, got to get to my back to the top though. My first run, and why don't we make this bigger? Oh, that's much bigger. We want to turn on the DeviceNet scanner. Okay, so we're going to come up and I double-clicked, double left mouse click. I come down. I want my controller tags. Oh, boom. So I turn off my program tags, and I want local 3 output, and there's the command register, and I want the run command. Okay, so now I've got, so I'm not typing any of these things in, I'm just going and getting them. All right, now I need to find the copy command. Okay, I'm back again. What I did is I hit Restore Factory Toolbar Layout to give me everything that I wanted it to give me, because I've been trying to find my tools and I can't find them. So I went to View, View Toolbar, and then Restore Factory Toolbar Layout, and now we're back to where I want to. I'm not back to where I want to be yet, but I'm going to be there pretty soon as I say OK. Alright, so now I said OK. Now I'm looking for the copy command, and it's probably going to be with the move guys. No, it's not with the move guys. There it is, copy. So there's the copy command, and I'm copying the input data. Okay, so down arrow, we want to only look at him, and we want to look at the data, and we want to look at data 0, because as you recall, that's where we put it in our scan list. if we were to put it in someplace other than data 0 on our scan list, then we would have had been looking for it there. Destination, I'm doing a left mouse click again to get there, and I'm going to put it in the drive input image. So drive input image, and the length of it is going to be 2. So I'm taking a double integer word from the PowerFlex, and I'm putting it in 2 integers in the drive input image. One of those integers is the speed, the other integer is the commands for making it work. Okay, now there is a issue here, because you notice on run 0, on run 0, the e's went away when I had it right. So I'm looking back on this and I'm saying, well, this guy's not right. We're supposed to be picking something different. We're supposed to be picking 0. So it would make sense to do what we did, but we can't do that. And length 2 means I get the 0th one and the first one, so that's pretty cool. Okay, now we need 1, 2, 3, 4, 5. And we'll move back to there. 1, 2, 3, 4, 5 runs that look like that, and with outputs. Now, all these outputs are there for is to give us indication that the machine's working right or not. So that's what that's all about. 1, 2, 3, 4, 5. Okay, I'm doing a left mouse click, and I want drive input image 0.0. Drive input image 0, come to the down arrow, .0. So I don't type it in, I go and I get it. And I'm turning on the drive status ready. Drive status ready. Okay, and then I want drive input image 0.1. Drive input image 0.1, and then I want that to read drive status active. Drive status active. If I don't get the ready light on, I can't be active. So there's something. So there's some hardware problem I got to solve before the machine will turn on. Next guy is the 0.3 guy. Image, input image 0.3, and we want drive status forward. So I'm looking for drive status forward. Then input image 0.7. And that's drive status faulted. Drive status faulted. Okay. And then we're looking for drive input image 0.8. And we're going to call that drive status at reference, which means that I'm at the speed I'm supposed to be at. I made it all the way up to the speed I'm supposed to do. Okay, now we need another copy command. So we've copied the, oh, well, it doesn't really matter. Okay, so we want another copy command. Compare, am I too far over? Math, miscellaneous, there it is, miscellaneous, copy. So I'm going to copy drive input image 1. Drive input image 1, and I'm going to put that into the drive feedback, which we called it slightly different than drive feedback. We said it was speed, and that's what it is, speed, and we want it to be length 1. You notice that again that all my E's are going away and it's correcting itself if I've spelled things correctly. I need 1, 2, 3, 4, 5, 6. Okay, so I need 1, 2, 3, 4, 5, and you notice in run 13 it's a normally closed contact, not a normally open contact. And then I'm going to need output energize guys on the other end. And then I'm looking at 2 copy commands, so if I go get those copy commands now, I won't have to worry about it later. And we remember that it's in miscellaneous file. And he didn't go down far enough. I got rid of him altogether. Well, thank you very much. All right, there we go. Excellent. Now we'll come up and continue doing what we're doing. Run 8, drive command stop. Now, the way we did that before is it was normally closed, but this is an active thing. It's going to actually stop it. And next one is drive command start. And then the jog command, which is obviously a big seller. We're probably never going to use it. And why Rockwell wants us to put it in is beyond me. And then we want a clear fault. And you say, well, how often are we going to fault? Well, every time we turn off power, we're going to fault. And so that's not good. And what's this guy? Command forward. And the next guy is not command forward, which really means reverse, right? And notice I didn't have to go get it because I was already using it, so I can go get it that way. Okay, back to what we're doing up here. And in run 8, I'm supposed to be the drive output image. Okay, drive output image, and it's 0.0. 0.0. And drive output image 0.1. and drive output image 0.2 and drive output image 0.3. Notice that when I use a bit, it shows me that I have. That's so I won't make the mistake of using it again where I don't want to. Drive output image 0.4. And in the PowerFlex, you can't tell it to go forward and reverse at the same time, and that's why we have drive output forward, drive command forward, not drive command forward. So I can't mess up and give them both at the same time. 0.5. Okay, then we're going to tell it what speed do we want. So the drive reference, and we added speed to that, is going to command output image 2. Well, actually command output image 1, which is the second one. Alright, and that's going to be length 1. So what we're going to do, what we've done is we have this drive output image that's going to give commands to the PowerFlex to do things, and the speed reference is the least significant of the 64 bits, the least significant word, and then we're going to copy drive output image, drive output image 0, drive output image 0 into the output command going to the PowerFlex, which is the data, but it's data 0. And length is going to be 1. Now this is an interesting thing what we're doing. You remember that drive output image is only a integer, and the local 3 output data is a double integer. But we're taking, what we're doing is we're starting with the drive output image, which is 16 bits at 0, and we're saying putting into something that's 32 bits. Of length 1. Well, the 32 bits length 1 trumps the fact that the first guy was only 16. So it's going to take both the drive output image 0 and the drive output image 1, the run 15, and put them both into the data 0 location. Okay, so now we're ready to do a download. We'll check the file first, and we see that there's nothing wrong. We'll go and do a download. Failed to go online with the processor because I haven't established a path. Oh well, up here is my path, and I'm going to go to the Ethernet, back into the backplane through there. Notice that it didn't light up saying that I could do any of those things until I got to the right spot. So if I set it there to the ViceNet scanner, what are you doing? You can't put a program there. What's wrong with you? So there we're fine. We're going to set the path first, boom, and then we're going to download the program, and download. Okay, and then we're going to put the program in, run, and we're going to see that my drive status is ready, and my drive status is forward. I'm ordering it to go forward. I am. I come down here and it doesn't seem, it seems like I should be ordering it in reverse. So the bottom line is there's something wrong, and what's wrong is that I need a wire hooked up on the power flex. So I'm going to come. Okay, I've been away for a little while trying to troubleshoot what my problem was, and it is rather embarrassing. The sync source switch on the power flex was still in sync, and because it was in the sync position, the power flex would not give me a drive ready, which it's giving me now. So right now I'm running at speed, which is 60 hertz, because I put in a 300 in the speed reference. I'm now going to go to reverse, and so I'm going to command, well, I am running in reverse, so I'm going to go command go forward. I'm going to look at the program tags, and I can see the speed from the feedback speed slowing down, going through 0, and then coming back up in the other direction. And when I get to 600 hertz, 60 hertz, my at frequency, at speed, at reference comes on. So I didn't get there in time to see it come on, it was already on. But right now the program is running fine. I had to, while I was off goofing off, I had to come back into the properties of this guy because his parameters were not set right. Even though he set them right before, I wasn't in COM port on 36 and 38. So I probably set it there and didn't say apply, or didn't do something. I didn't keep it. So I had to do that. Plus I had to go, and I had a hardware problem in that my sync source switch was not in source, which it needs to be in. And this ends, and you can, I think you can hear the motor running in the background. So I'm going to turn off the motor. And you can hear it winding down to nothing, maybe. Not sure whether or not you can hear that or not. Okay, and that ends project number 1.